Hi, today we're looking at substitution for definite integrals. We pretty much will end up doing this very similarly to what we did when we had indefinite integrals. We're just now having the values that our integral is starting at and ending at. So we'll be doing our u substitutions where if we substitute u for g of x and du as g prime x, d of x, we can say our integral from a to b of f of g of x times g prime of x dx is equal to our integral from g of a to g of b of f at u du. So we'll look at some examples. So for example, evaluate, we've got the integral from 0 to 2 of x times x squared minus 1 dx. So we're going to say let u equal x squared minus 1. Now we know that du dx of x squared minus 1 would be 2x. Now, we can see we have an x here. We don't have a 2 there, so we want the x somewhat on its own, but we also want the dx with it. So I would multiply both sides by dx. We've got du equals 2x dx, and then divide both sides by 2, so du over 2 equals x dx. And then we will substitute. So we have the integral of, this is replaced with u, so u squared, du, dx gets replaced with du over 2, and I would factor that 1/2 out, so we've got 1/2 times the integral of u2 du, so this would be 1/2 times 1 over 3 u cubed. And then at this point, I would substitute our original equations back in. So we have 1/2 times 1 over 3 of x squared minus 1 going from 0 to 2. Now we can also factor that out. So this becomes 1 over 6. That's x squared minus 1 cubed going from 0 to 2. So this would be the same as 1/6 times 2 squared minus 1 cubed minus 0 squared minus 1 cubed. So that would give us 1 over 6 times, let's see, 2 squared is 4, minus 1 is 3, 3 cubed is 27, minus 0 squared is 0, minus 1 is negative 1. Negative 1 cubed is negative 1. So we've got minus and negative. So that would be plus 1. So that gives us 28 over 6, which reduces to 14 over 3. Okay, so we'll do another example. Okay, so we have an integral from 1 to 3 of x squared minus 5 squared 2x dx. So we're going to say that x squared minus 5 BU. So du dx is equal to 2x. Now, if we rearrange this, du equals 2x dx. So essentially, we are going to be replacing x squared minus 5 of u and our 2x dx by du. So this will equal our integral of u squared du. So that'd be 1 over 3 u cubed. Now I would move for 1/3 out, so that would be 1 over 3 u cubed. And then we'll substitute in our equation for u. So we've got 1/3 times x squared minus 5 cubed. Now we're going from 1 to 3. So we've got 1/3 times 3 squared minus 5 cubed minus 1 squared minus 5 cubed. That gives us 1/3 times 64 minus 64. So that's going to give us 0. In next example, we have integral from 1 to e of the square root of the natural logarithm of x divided by x. So I'm going to say u is equal to natural logarithm of x, which makes du dx 1 over x. Or rearranging du is equal to 1 over x dx. So this part here cancels off that. We substitute in 1x for that. Now this one I'm going to do a bit different from the other one. I'll get to that momentarily. So I've got my integral of u du. And actually, sorry, my ln x is inside the square root. So integral of the square root of du. Now, so far, I've done the integrals and then put in our original equation, but we don't technically need to do that. So I'll show you another way that we can do it. So we are going to from 1 to e before, so we'd have to figure out what we're going from and to if we have a variable u instead of x. So we said that u was equal to ln of x. So we'll figure out u's starting value from here. So if we have u equals ln natural logarithm of 1, that's 0. So we're starting at 0. And then if we look at our final position, we have u is equal to natural logarithm of e. That's just going to give us 1. So we're going from 0 to 1. Now, if we look at our integral of the square root of u, that is just going to give us 2 over 3, u to the 3 over 2, and then we're going from 0 to 1. Or 2 over 3 times u to 3 over 2, going from 0 to 1. So we've got 2 over 3 times 1 to power of 3 over 2 minus 0 to the power of 3 over 2. and that's just going to give us 2 thirds.